Okay, today's video is about limiting factors.
Oh, it's so sad.
Why is it sad? Anyway,
It's sad.
joining me today is, unfortunately, Mr. Lencioni. Although he is a smart guy, so it's a trade-off between maturity and intelligence.
Oh, so sad.
But anyway, so, anyway, we're going to start with a little review. The last video you saw, we talked about these two terms, carrying capacity and biotic potential. What is carrying capacity, Mr. Lencioni? Do you know?
Yeah, I know. Come at me, brah. Carrying capacity is how much the environment can support of living things.
Of a population, right?
Of a population.
Yeah. And then biotic potential is,
Happy baby land.
yeah, if nothing ever goes wrong ever, how much can grow.
And everything can make a lot of babies.
Yeah, everything reproduces.
It's gross.
Everything reproduces optimally. There's
No death.
no death. Yeah, things like that. How high can a population get to? So as we mentioned at the end of the last video, every environment does have a carrying capacity. So biotic potential is never totally reached.
No.
I mean, things can grow really, really fast, but at some point it is going to taper off.
What
because
goes up?
there's a certain capacity. There's certain things that stop populations from growing. That's actually what today's video is about, is the kind of things that do stop populations from growing. So population size, whenever you notice the number that's assigned to a population, it's really just normally if a population is at like equilibrium, for lack of a better term, that means there's a nice balance between its highest potential as well as the resistance that the environment puts against reaching that potential. So this was also on your last notes, but what is population density? Well, that's the number of individuals per unit of space.
I can see you in there.
People divided by space. Yeah, I'm not in that picture.
Yeah.
But anyway, the reason I bring that up is because we're going to talk about things that limit a population that are dependent on population density and things that aren't. So this does become important. So first, here's the big term, limiting factors. A limiting factor is anything that prevents a population from growing any further. So for example, what stops a population of bacteria like in a petri dish when we did our lab earlier? Or in your
my
yogurt. Or in your yogurt.
Well, there was probably a couple million in here, lactobacillus, and now they're gone.
But so why couldn't, before you even open it up, why could they only reach a certain population?
That's not that big of a jar.
Right. And like the petri dishes we grew in class,
Yeah.
it's only a certain amount of space,
Certain
right?
amount of food.
So space is a limiting factor. Yep. Or amount of nutrition that's in there for it. Or predators, you eating the bacteria, right?
Delicious.
Yep. So anyway, now we put our limiting factors into two categories. We have the density dependent factors and the density independent factors. And density dependent factors are are limiting factors that their effect on the population is either made stronger or weaker based on the population density in an area.
Like how cramped it is, right?
Right,
Okay.
right. They'll usually be devastating in packed areas. Density independent factors are ones that will affect all populations no matter what their population density is. So it's kind of like a, we'll get to the thought.
Yeah,
Let's
examples.
I was going to start listing off examples, but one step at a time. So anyway, some density dependent factors are space. Often that space is going to become a factor in a more dense population.
Like if
right?
we're all like close or whatever.
Yeah. So food is also a density dependent factor.
It's mine.
Usually you only see this become a factor in areas where the population is very dense, right? Stress, usually people get, there's a certain amount of stress when you have overcrowding.
Working with this guy.
yeah.
Am I right?
Yeah.
You guys.
Well, we're not even talking about humans here, though.
Oh,
either.
you're right.
Like, if you put a bunch of...
Oh yeah, like in the cows and stuff. Like I read an article once where it was like beef production or lamb or pigs, and they would cram these train cars full of these animals, or like to relocate them and move them, and then when they'd open the train car, half would be dead just because they were too stressed. Their little piggy hearts couldn't handle it, or I don't know.
Yeah.
It was a bummer.
That predation. So the reason predation is density dependent is because if you're a wolf, are you going to go look for rabbit prey in an area where it's high density or low density?
Yeah, right. High density, obviously. Hey, there's no rabbits here. I'm gonna hunt.
Disease is able to spread more rapidly in crowded conditions. Yeah, that's why. Because when symptoms tend to spread easier in dense populations, because like cases of sneezing or any disease that can spread from contact, you're going to have much more content in a dense area. Finally, parasitism, which is kind of related to disease, but a high density.
Ooh, I don't know how to spread a parasite to you. I was gonna say
Yeah, please don't do that. But anyway, so you get the picture.
Do you want to talk about the Black Plague, or do you do that in class?
I'm going to do that in class.
All right.
Yeah. But, yeah, I do more of the human growth stuff in class. So, anyway, density-independent factors are ones that... This gets a little confusing, because density-independent factors are factors that they're going to have the same amount of power, whether they're in a dense population or a less dense population. It gets a little confusing, though, because especially my first example and my third example, so weather and natural disasters. Now, obviously... And I teach us physical science. If an earthquake happens right in the middle of Chicago, as opposed to out in the middle of the ocean, it's going to kill more people in Chicago, obviously, because there's more people there. So you think, wait, isn't that density dependent? But what this is saying is the actual force of the earthquake does not matter based on where it is. Okay, a 7.5 earthquake is still going to have the same amount of power no matter where it is. So its power itself is not actually affected by population density. In the case of disease, it is because it is more easily spreadable because of the people that are there.
The earthquake doesn't spread easier more easy in Chicago.
Yeah, because there's people there. So that's what we're saying is these are things that are totally they're not affected at all by humans or whatever population. It shouldn't just be human-centric here. But anyway, amount of available energy is actually a density-independent factor.
Yeah, it's not the desert didn't pick where people aren't. There are animals. They're like the desert's not like, hey, there's nothing that lives here already. Let me come in. It's like, no, the desert's just the desert.
Yeah, and then also humans. I would argue the limiting factors we introduce in the environment are kind of density independent because we don't really look at population density of the animals there.
If you
knock down trees and stuff.
If we find oil in the middle of the ocean, we'll go get it. If we find oil in the middle of a field of cute bunnies, bunnies.
Might have to talk to a congressman, but basically got to go after it, right? So here's how this applies to a logistic growth curve. If you forget what a logistic growth curve is, I would pause the video and look back at your notes from the other night, or else it's totally going to get lost on you. But anyway, time, by the way, I'm noticing that's cut off a little. It's time at the bottom, the time interval.
In years.
Yes, in years. So the very bottom, there we go, or not the bottom, but the middle, right where that arrow was pointing, that's the point in which limiting factors actually start to affect the population.
Really?
When the line is kind of going at this slope up, but then suddenly, it starts to level off a little bit. That point where the slope is not increasing anymore, that is where, limiting factors have started to kick in. But that said, it's not making a significant impact quite yet.
Right.
But not all members of the population are obtaining enough resources to survive at that point. Now, at the very top, and that's cut off a little, it says the point in which limiting factors prevent the population from growing anymore. There is a point in which there's so few resources that the population can't possibly grow any higher. And that is where it levels off there.
It's depressing.
A little sad sometimes. And that is, what do we call it?
The carrying capacity.
Yep, and there you go. The carrying capacity, that's the maximum number. We've already gone over this. But,
I remember this.
Maximum number of individuals that a population environment can support. And this is because there are limiting factors knocking them down. Now, here's the really sad fact. If a population reaches carrying capacity, so let's say the carrying capacity is 1,000 and there are 1,001 individuals, there are not enough resources to help everybody. So what needs to happen? Someone needs to die. It's really sad. But if there's really only enough resources for 1,000 individuals and there's more than 1,000, fortunately, there's not enough. All right, so anyway, and this is a very important point here, though, that once population reaches a carrying capacity, you start to see a lot higher death rate in the population. And that's actually it. So make sure you do your checkpoint. Mr. Lencioni, thanks for helping.
No, you don't believe that.
See you later.
Have a great day.